an honour being invited to be the first speaker at this 7th International Workshop on Sustainable Road Freight. I've packed a lot into this presentation. There's a high density of graphs and diagrams, so I'm going to keep my introductory remarks to a minimum. I would like, however, to say a few words about my university, KLU, which is just celebrating its 10th anniversary. And over the past 10 years, we've achieved a lot in research and teaching terms. We've also just launched a new research centre, which is going to be specialising in sustainable logistics and supply chains. The theme of my talk today is to look beyond the intensifying debate in Europe over choosing the right powertrain technologies for decarbonising long-distance road freight. I'm not going to be presenting technical evidence here on this comparison. I'm going to leave that to the engineers in the event. Instead, what I'm going to do is look at some of the wider issues and see them within what I call a logistical context. I'll start by emphasising how important it is that we act quickly to reduce carbon emissions from the road freight sector. In 2018, the Intergovernmental Panel on Climate Change presented some figures suggesting that to stay within a 1.5 degree temperature increase by 2100, we had a carbon budget of only 420 gigatons of CO2 left. We were emitting emissions then at about 42 gigatons per annum. So the arithmetic is quite simple. It would suggest that at that rate, we exhaust our budget by the end of the 2020s. And if we think what that means for the decarbonisation of European road freight, for example, I put on this graph a couple of trajectories. One would see the emissions from road freight peaking in 2025 and then dropping steeply to 2050. I mean, the EU is currently planning to have a 90% reduction in emissions by 2050. Alternatively, we could delay until 2035 and then have a steeper reduction in emissions. If we did that, in the meantime, there'd be about a 28% greater accumulation of CO2 emissions. And remember, it's the accumulation of these emissions which essentially drives climate change. So we got to do this rapidly. I mentioned the powertrain technologies. These are the main ones, obviously: battery-powered vehicles, hydrogen fuel cells, electrifying the highways with overhead catenaries, using synfuel or biogas. And to complicate things, there are various hybrid permutations of vehicles as well. There have been several studies done in recent years comparing these powertrain technologies. I've simply selected two here. One is by the Eco Institute using German data, and then more recently the strategy and team of PricewaterhouseCoopers last month published a very interesting report. Hard to compare the results of these studies because they use different criteria and some of the assumptions differ as well. But most of them focus on things like total cost of ownership, the recharge rates for batteries and refueling, the distance ranges of the vehicles and so forth. But currently there is great uncertainty over the future rates and costs of decarbonising electricity, for example, or providing the necessary infrastructure to support these alternatively fueled vehicles. Also worth noting that in Europe, some of the large truck manufacturers have adopted differing powertrain preferences and strategies. And there's just general uncertainty as to how we're going to transform this huge trucking market in hopefully what will be a short time. I think there's general agreement, however, that there's no one technology is going to triumph, and that almost certainly these technologies will coexist and will compete, and will probably serve different sectors of the market because these different powertrain technologies will have differing operational sweet spots. I've tried to illustrate this subjectively in these graphs using two criteria. One is payload weight and the other trip length. Now, obviously, there's going to be a fair amount of overlap between their respective sweet spots, but no doubt there will be some carriers whose operations result in them using a particular powertrain technology. But remember, a large proportion of trucking companies, certainly in Europe, are what we would call general hauliers, doing a whole variety of work. And they seek operational flexibility. They're looking for standard workhorse vehicles that would allow them to carry different categories of product over different distances. And for them, it might be a tough decision to decide on one of these technologies. Also, there's a problem with what we might call this multiple technology scenario, because it risks spreading the available capital investment in truck manufacturing capacity and capital available for energy infrastructures too thinly. And as a result, we may lose out on some of the potential scale economies. Um, but whatever of these technologies proves to dominate, either individually or collectively, we have to face the fact that we're going to remain very dependent on diesel-powered trucks for the foreseeable future. Study done by Boston Consulting Group and Prologis for the German Industry Association BDI a couple of years ago suggested that by 2030 in Germany, 70% of the trucks will still be diesel powered. The PricewaterhouseCoopers report I mentioned a moment ago, their calculations relate to Europe and also to Turkey, suggesting that by 2030, 90% of the trucks on the road will still be diesel powered. Now, of course, those diesel-powered vehicles will become more efficient through time. The EU fuel economy standards, I think, will ensure that the new vehicles coming onto the market by 2025 will be at least 15% more carbon efficient, and by 2030, 30% more carbon efficient. So the diesel-powered vehicles will be lower carbon. The European Commission is wielding the big stick here and imposing what are quite punitive penalties on truck manufacturers if they don't achieve these fuel economy standards. But there's a limit to how much you can do in a regulatory way on the supply side. We have to look at the demand side and ask how quickly it will be before operators of trucks switch across from diesel to these alternative technologies. The graph at the bottom there shows the fleet size in different EU countries. Not a widely known fact that the country with the biggest truck fleet in Europe is Poland. If one looks at the 2017 data for truck renewal, it would take Poland almost a quarter of a century to replace its current diesel truck fleet. Germany replaces vehicles more rapidly. It would take about 10 years, but even so, quite a while. If you do the calculation for the EU 28 as a whole, again using 2017 data, that would suggest that replacement of diesel vehicles by alternative ones would take almost 13 years. And if you weight that figure by national road ton kilometres, the average would be about 14 years. Now, of course, one could accelerate that vehicle replacement rate using tougher regulation or perhaps financial incentives. But there'll be forces pushing in the opposite direction. For one thing, as haulage companies emerge from the COVID crisis, many of them will be in a fairly weak position financially and will probably be extending vehicle replacement times rather than reducing it. The total cost of ownership of these vehicles will be higher than those of diesel vehicles, and that will be a deterrent. There was a lot of uncertainty about the depreciation rates for these new vehicles and what the residual values will be in the future, and then the rate at which the supporting infrastructure can be developed, either if we electrify highways or if we put in place battery charging or hydrogen supplies. That's going to take time as well. So yeah, one can be a bit pessimistic about the speed at which this transformation of the European truck fleet is. I think that maybe we should look beyond the current preoccupation with truck technologies at the other decarbonisation measures we can implement in the shorter term, many of which have quite a low carbon mitigation cost. Now, this is a type of graph I borrowed from David Seaborn. I apologize, David, for using your material. What I have done here is looked at the carbon abatement potential of different decarbonisation measures and compared that with the ease with which those technologies these decarbonisation measures can be implemented. I've differentiated those which are technological from the ones which are the softer operational, managerial, regulatory measures. And from the work I've done in this area over the years, it seems to me there's a strong technology, energy supply bias in much of that work, and an underestimation of the potential contribution that can be made from what we might call these logistics management measures. Some of them, I'm aware of two in recent years, to try to quantify the contribution of these logistics management options to road freight decarbonisation. So the International Energy Agency, for example, back in 2017, in constructing its modern truck scenario, allowed for measures which would reduce the total amount of road freight activity, for example, switching freight to alternative modes, or also loading the vehicles better. In that report, they also reckoned that about 40% of the reduction in fuel consumption in global truck fleets would come from logistics measures rather than from technology. And then more recently, the Energy Transitions Commission, in its Mission Possible report, actually disaggregated these logistics measures and tried to estimate the saving in CO2 emissions by 2040 that might be achieved by things like supply chain collaboration, modal shift, moving to more efficient vehicle driving. And in another study, they suggested that by 2050, these demand management measures might cut CO2 emissions from heavy road freight by 28%. But there's a problem with all of this. These projections are optimistic, but there is still limited evidence that the key logistical metrics here are moving in the right direction. If we look at the situation in Europe, take modal split, for example, since 2012, the road network has actually been increasing its share of the freight market rather than reducing it. If we look at empty running, there's been a marginal improvement in empty running over the past 8 years, but nothing very impressive. And then finally, the average payload weight of trucks in Europe has remained fairly stable now for almost a decade. Now, average payload weight is a rather poor way of measuring vehicle utilization. It takes no account of the loads that cube out, that reach the volumetric or deck area limits before they reach the weight limit. Almost 10 years ago, I wrote a report for ACEA, the organisation that represents truck manufacturers in Europe, in which I outlined the deficiencies with current statistics, macro level statistics, and much of my criticism was levelled at the measurement of vehicle utilisation. I pointed out that to do climate modelling in the road freight sector, one needed to improve the way in which we measure the utilisation of vehicles. But 10 years on, regrettably, very little has changed. I remember fondly the work that we did in the UK between 1997 and 2009, and what were called transport KPI surveys, when we developed a different methodology really for trying to measure the utilisation of trucks across different supply chains. Regrettably, that programme came to an end in 2010 as a result of government austerity measures. Just to digress for a moment too on the utilisation of trucks in Europe, the EU mobility package, which is currently being implemented, has a regulation which may actually result in empty running increasing across Europe. This is a regulation which will require trucking companies to return their vehicles to their point of establishment in whichever country they're registered at least once every 8 weeks. Now, this is essentially a social measure. It's done for a very laudable reason, to improve the welfare of truck drivers. But when the measure was approved, there had been no assessment of its likely environmental impact. Now, I must declare an interest here because the European Commission has, in the meantime, engaged Ricardo to measure the CO2 impact, and I'm an advisor to that study. But if you just think of the implications, that if an Estonian carrier, for example, was doing cabotage work in Spain and then had to bring the vehicle back empty to Tallinn, shall we say, almost 4,000 kilometre journey from Spain. If it was a Polish haulier doing work in France, then the return journey from Paris to Warsaw would be 1,600 kilometres. Now, There has been a study done recently by KPMG using Bulgarian data, and that suggested that for Bulgarian hauliers returning, they'd be, on average, returning over a distance of 2,000 kilometres. They estimated that about 46% of those trips would be empty. And KPMG are suggesting that as a result of all of that, there may be a 2% increase in CO2 emissions from international transport. So that's one trend which potentially direction. But we could ask, what do we need to do to ramp up the contribution that these logistics management options can make to the decarbonisation of road freight? Well, I'll suggest a few things. One is companies, that's both the users and providers of road freight services, committing to net zero carbon targets. There are, I think, about 1,100 companies now in the world which have committed to being zero carbon by 2050 or earlier, including some large logistics providers like DHL and Kuehne+Nagel. Now, this will apply across the entire spectrum of their operations, including transport, and that, I think, will exert downward pressure on emissions. We can also promote more what I would call carbon sensitive road freight procurement. Draw your attention to a very interesting report published last year by the Smart Freight Centre, where they give companies guidance on how they can purchase freight transport services in a way that minimises carbon emissions. We also have to engage the vast number of small operators in the road freight sector. In Europe, we've got over 500,000 of these small carriers. They have to be given advice on how to measure and reduce their emissions. They have to be incentivized. Unfortunately, some of the survey evidence we have isn't encouraging here. Transporion did a survey of 1,200 small road freight carriers in Europe recently and found that about 43% of them claimed they couldn't even calculate their CO2 emissions. So this is going to be a tough challenge, but we really have to get on and do this. There's the digitalization of logistics. Digitalization is a sort of collective term that's being used for a whole suite of computing and IT technologies. General agreement that all of these things collectively will help to drive down CO2 emissions. To my knowledge, nobody has yet quantified the scale of that carbon reduction, but it will be large. And then finally, for me, the big game changer here ultimately will be attaching monetary values to greenhouse gas emissions. That's already progressing quite impressively around the world. If you look at the World Bank's dashboard of carbon pricing initiatives, the ones currently in place or being planned, if they were all implemented, they would cover about a quarter of greenhouse gas emissions worldwide. And that will then put carbon emissions into the balance sheets of companies, and I think will change the managerial mindset. But the question is, how easy is it going to be to incorporate the road freight sector into carbon pricing schemes? And I think the answer to that is not very easy. The feeling is because it's such a highly fragmented sector and also one which is subject to a lot of illegality, it's not going to be easy to do that. But again, we should be making the effort. That world map is a nice segue into the final section of my presentation, where I move from a European perspective to a global perspective, with the help of some data from the International Transport Forum, because in its Transport Outlook report published last year, you find the graph on the left there, which is the ITF's projection for the reduction in the carbon intensity of road freight in different parts of the world up to 2050. Now, earlier I've outlined the constraints which are going to limit the decarbonisation process in the EU, but despite that, as you can see, the expectation is that the EU will considerably outpace the rest of the world in its rate of road freight decarbonisation. And unfortunately, it looks as if the rate of decarbonisation is going to be relatively slow in Africa and India, for example. And that, which brings us to the graph on the right of this slide, again coming from the ITF, which looks at the projected growth in CO2 emissions from road freight transport up to 2050. This is using what they call their current ambition scenario, and distinction between OECD countries and non-OECD countries. And you can see there how most of the growth in road freight related emissions will be in those non-OECD countries. In fact, by 2050, the expectation is there'll be 3 times as much emissions coming from those countries. So we have to face the fact that the those countries where the growth in emissions from road freight is going to be highest are also the ones where the rate of decarbonisation is probably going to be slowest. That, I think, is for reasons that we're all well aware of. If you think of all the constraints on the energy efficiency of road freight transport in less developed countries, it's a whole host of things. It's the fact that many of them still have diesel fuel subsidies. There's a table from the International Energy Agency last year showing just how much subsidies represent, they call it the price of fossil fuel, um, which is keeping old fuel inefficient trucks price competitive, and it may take some time to remove those subsidies. Road infrastructure is obviously very poor in many of these countries. The World Economic Forum regularly reviews the standards of infrastructure, and of course that then impacts on the fuel efficiency of the freight operations. There's chronic traffic congestion. Many of the vehicles are still old and under-maintained. There's the lack of skill in driving many of these vehicles, lack of training to drivers in many of these countries, and the principles of eco-driver training, and missing out then on what has been shown in Europe and North America to be sizable improvements in fuel efficiency from driver training, and also putting in place telematic monitoring of drivers. I've reviewed the literature list recently. You can get between 5 and 10% fuel savings from both of these things. There are obviously intense commercial pressures to operating in these countries, making it very hard for small carriers to replace their vehicles, or to retrofit equipment, or even to train their drivers. And then there's weak regulation as well. There's low compliance with those regulations. So far, we've seen limited development of fuel economy standards across much of the developing world. And although these standards are now in place in Western, more developed countries, again, there'll be a sort of 5 to 10 year time lag, probably at least, for these standards to um, be diffused, if you like, in imported vehicles into other parts. Which leads me to my final slide, which looks at the reasons for thinking that there's going to be a fairly slow diffusion of these low carbon powertrain technologies into less developed countries. I mean, it's going to take a while to develop battery recharging networks and gas fueling networks, if it's biomethane or hydrogen that's used to decarbonize. Many of these parts of the world have relatively carbon intensive electricity currently, and the rate at which grid electricity is decarbonizing is relatively slow. The other worry is that even as these countries do decarbonize their electricity, will there be enough to support an electrified truck fleet? If countries decide to pursue the e-highway strategy and invest in machineries, again, how long will it take for that to happen? What about the availability of hydrogen and biogas supplies? What about the affordability of these low carbon vehicles in countries where the average carrier has very limited capital resources available? And what about the import market for these vehicles? Because so many of the vehicles in the developing world are imported from North America or from Europe. What we're going to have to see is a transformation of that global market and of the global supply chains in used trucks. And that's going to be problematic. Because one thing that could well happen is that we'll see a surge in exports of these older diesel-powered vehicles, because as Europe and North America moves to electric or hydrogen-powered vehicles, there'll be a desire to offload the older diesel-powered vehicles, and so that might cause a surge in imports in these countries, which may actually reduce the price of these second-hand diesel vehicles, which will make it harder to make the switch to low carbon vehicles. And the other thing is that the low carbon vehicles will have a longer working life. That's going to be the case certainly for battery powered vehicles. And therefore it will take longer for the next generation of low carbon vehicles to enter that global import market. Another important issue here is the scarcity of the materials we will need for fuel cells and for batteries. It's likely that many Western countries will be reluctant to see those materials exported in vehicles. They would the expectation is that beyond 2040, we're going to have to rely very heavily on the recycling of materials like cobalt and platinum for these vehicles. So we may have to think then in terms of different value chains developing, not just for the basic chassis of the vehicle and the engine, but also for um, the scarce materials required for electrification and hydrogen. And then if that switch from diesel powered to low carbon vehicles is relatively slow, then of course governments may have limited incentive to convert the infrastructure to accommodate these low carbon vehicles. So it's not difficult to construct a fairly negative scenario about the globalization of the decarbonisation of trucks. Um, you know, why don't we just get rid of the damn things? They cause such problems environmentally and economically. This is a photograph I saw recently of a haulier in Kent. So I'll leave you with that thought and be happy to answer any questions that you may have about this presentation. So thank you very much for your attention. And there's always my book on decarbonising logistics, which you may wish to read. Thank you.